Video problem number 47, more limiting reactants. I'm not going to lie to you, this is the problem that all honors students mess up. All AP students mess up. This is a difficult idea because it's a lot of steps, all right? So it says determine the amount of excess reactant remaining when 76.4 grams of C2H3Br3 is reacted with 49.1 grams of oxygen. And then it says see previous work in video problem number 46. So let's look back at video problem number 46 real quick. So it's this upper one right here. So we had all this work. I'm going to grab this work for us real quick. So I'm just going to take a picture of it, basically. I'm going to grab all this, bring that over with us to here, paste it, and move it up here to the top. Come on. Walk with me. Oh, will it not go over the top of it? There it goes. Okay, so there we go. So this is our work. So 76.4 grams, 76.4 grams, 49.1 grams, 49.1 grams. So what we did was we found the limiting reactant right here. All right. So we said that the limiting reactant was the C2H3Br3. And now what we want to know is how much of this excess is remaining, right? Determine the amount of excess remaining. Okay. So we know that we run out of C2H3Br3, and what we're trying to figure out is how many grams of oxygen do we have left over when I run out of that C2H3Br3. Okay. So what we're going to do, let me draw a little line here to sort of break it off here. What we're going to do is we're going to take our limiting reactant and figure out how much oxygen we actually need. Right? So we know that we have 49.1 grams of oxygen. So let me just jot that down. I say we have 49.1 grams of oxygen. How much do I actually use? That's what I'm going to answer. Okay? So I'm going to take 76.4 grams of C2H3Br3, and then I'm going to convert that, well, first to moles. I already got the molar mass, so I'm just going to use that. 1 mole for every 266.7444 grams. Okay, so that's going to get me moles of C2H3Br3. Let's go ahead and get that number here. All right. So before I go on, let's get that number. Pick up the calculator. 76.4 divided by 266.744. So that tells me that I have 0. Let me screw this up. 0.286 moles of C2H3Br3. Now, what I want to know is how many moles of oxygen do I need to react with all of this C2H3Br3? So I'm just going to convert my 0.286 moles of C2H3Br3. I'm going to convert that to moles of oxygen. So I've got oxygen on top, C2H3Br3 on bottom. What's the mole ratio? It's 11 to 4. So 11 oxygens for every 4 of those, right? So I'm going to take that value that I have in my calculator, I'm going to multiply by 11, I'm going to divide by 4, and I'm going to get some value. And that value is 0.788 moles of oxygen. Now, that's how much oxygen I need to react with all of this C2H3Br3. Okay? So that's how many moles of oxygen, I already forgot moles of oxygen. That's how many moles of oxygen are needed. Okay? Let's go ahead and convert that to grams, because a lot of times we can understand grams a lot better. So I'm going to convert that 0.788 moles of oxygen. I'm going to convert that to grams. Right? So that's 32 grams per 1 mole. I'm going to take that value that's in my calculator, multiply by 32, and I get a value of 25.2 grams of oxygen. Okay, so remember what we said. We said we actually have 49.1 grams, right? That was the value given to us in the problem right here. 49.1 grams, okay? How much do I need? Well, I need 25.2. So that's how much is needed. So that's how much is needed to react with all of this C2H3Br3, right? So I start with 49.1 grams of oxygen, right? I use 25.2 grams of oxygen. So what I end up with is the difference, which is 23.9 grams. Technical difficulties, give me 1 second. Here, we're back. Okay, maybe. Okay, we're back. Again, OneNote's crashing on me. I think my computer's getting too hot. So I've got 49.1 grams. That's how much I actually start out with. I use 25.2 grams. That leaves me with, oh boy, maybe not. There we go. That leaves me with 23.9 grams of oxygen. Okay, so how much is left over? 23.9 grams. How much of the C2H3Br3 is left over? None, 0 grams. That's my limiting reactant. That's the one I run out of. Okay, I'm left with this much. Now, if you ever get to this point and you get a negative value, you pick the wrong limiting reactant. Go back, do the whole thing again. Okay, you did it wrong. You just messed up.